So physics lessons often lack in experiments, and hence students have a hard time of understanding physical context. We will provide teachers with the assets to fix this problem by using Multito as an input device for multi-student interactive simulations. We enable them to show their students a lot better visualization than conventional equipment could achieve, and without the abstractness of common simulations. So in order to learn how to do experiments with students, we went to the Xtarium and visited Dr. Axel Werner during our contextual inquiry. And we wanted to get to know what he does with his students who come there and how he does this experiment. Our main insights were that we had to keep the experiment simple. In order to have the students understand the experiments should be linked to something related in their lives. So we shouldn't use equipment from laboratories, but probably we should use equipment everyone has in their kitchen. The second person we were interviewing was Sven Landschreiber. He is a teacher at the Schiller Gymnasium in Potsdam. And we went there to learn what experiments are conducted in schools and how they are integrated in lessons. We learned from him, for example, this task. This is a double-slit experiment conducted in a wave and ripple tank. So water waves are projected on the area in front here. And it's a very time-consuming preparation. So he has to fill the water in, configure the generator, configure the strobe. And in the end, you have a more or less good picture of some black and white stripes which you can interpret as waves. But it's not very good, and it takes a lot of time to prepare. And the most important thing, students cannot perform these experiments themselves, because the school has one of those ripple tanks and the teacher has to present the experiment. So our main insight from Sven Landschreiber was students have to perform experiments themselves in order to understand the physical context, but schools do not have the proper equipment to do so.
And the last person we interviewed was Andrea Köhn. She's also a teacher at Einstein in Potsdam. And she showed us a thing called the Warnlernplan, which is basically a piece of information where every teacher knows what experiments and what data their students have to learn, and that is a guide for us to stick by, because now we know what experiments are conducted in school. A task sheeted or an experiment sheeted, this is also a wave simulation. This is a wave simulation from the top, it's from the side. So you can fix the left hand, you can move the right hand up and down, and as you can see on the right, it's the copy of the book. And the wave moves from the right to the left, and you can perform experiments like reflection if you fix the end, or you can just create stationary waves if you move both ends. Our main insights from Frau Köhn were that she likes to show experiments as an introduction, so she wants to introduce the students to new phenomena, and she doesn't use experiments for exact measurement. And she thinks it's also important that the students conduct experiments for themselves, so the practical abilities, the skills, are as important as the theoretical knowledge. And as the last point, as the last main insight, she thinks that for her students, it's very important that the students have different views on the same experiments. So as you see here, you have a top view, you have a side view, that's important for the students so that they can comprehend the view. And now we'd like to do a little walkthrough, and we'll have an experiment. We'll show you the Green-Bernard principle. So we have a sandbox, and we can create different objects, different modules to build up the experiment. First, what do we need to build some walls. Okay, we're clicking on build. We are selecting a wall, and now we have a standard shape, a rectangle, which is a wall. And now we want to modify this shape. So the user should be able to modify it by a law relatively simple. Just click on that point of the shape you want to modify. We want to move it. So we are selecting this point, tapping somewhere else, and then the shape gets modified. So we are doing this to create like a barrier with a little split in the middle. And now we have one thing left. We have to prepare a generator. We are doing this the same way we are generating the wall. hole in the middle of this point, so it's a new wave, and as you can see, it travels in a circular shape. And we talked about the different views and experiments, so we introduced inspect view, where you can basically select one or more points. In this case, here only 2 points, and we slice through the experiment, we cut through the experiments, and have therefore a detailed view where you can, for instance, analyze the wavelength or the amplitude of the experiment. So that was our walk, our idea of the experiment, and thanks for listening.
Alright, cool. So sorry for being late. Great stuff. So first of all, maybe I hope you have more of this. I would like to show a video from the contextual inquiry. I mean, it's nice to see the face of the people, but it's just great. I mean, just for any kind of presentation you ever give, you'll be able to show more stuff if you use the verbal channel and visual channel at the same time. So do that. I had a question about the interface. So you essentially have like a drawing program and you can modify these things. Is that necessary, or would you do better if you just had like 20 different primitives that people can, So there's something called Gary's mod in Half-Life too. Just an interface that allows you to just drop everything into the world, just a big repertoire, make like a file and have that and wheels and rock around with it.
And our idea was the shape we use are somewhat limited, but it's very simple to modify the shape. So what we're using, we want to use squares in different sizes, and we maybe want to use a triangle. And to get from a rectangle, from our default shape to a triangle, it's not very complicated. So we
it depends on how well you snap, and it's just like, I think let me ask another question first. Like, what is the most complex experiment that you plan on doing? So I understand double slit, right? Double slit is, it's a classic, makes sense, right? So what is the most complex experiment that you'll be able to run? Because in some ways, the functionality you offer depends on what functionality you want to offer. If double slit is all you want to do, then you just offer double slit, right?
Well, there are experiments where you have to send waves on a diagonal shape, like a triangle or something like that, so the wave gets broken inside.
Yeah.
It's probably a little bit complicated, more complicated than just the slit.
Yeah.
But the most important thing for us, why we wanted to provide the user with the ability to change the shapes, was that we hear from the teachers they use simulations and they are very, very restrictive. So they say, okay, these are your shapes.
Okay, so I think what's important is that you think of the. I'm sorry for being rushed today because we're going to see some of the presentation. I think what's important is maybe this is less about what you did, but what you should be doing. So I think in order to get your design right, you should know all the things that you want to do to offer the right functionality that allows you to do exactly what you want to do. And you can have like control points and change the curvature of these things, right? If you want it, the question is, do you need that, right? Maybe you do. Maybe you want to have a lens. Maybe you want to have a curved surface that's round, and so the wave that falls into it gets reflected, and focuses again. You could start having. If you look at folks in quantum molecular dynamics, you can have a lot of fun. You can have refraction ratings. I can give you fantastic folks that will make fantastic experiments in this thing, right? How to reflect the wave, for example, is with our path is what we do with this. So I would encourage you guys, and maybe that's for everyone. So think about. There will always be like a simple experiment that you can do, or like a simple thing to make. But think about also like a stretch goal, like a complex thing. Or ideally, to make it work within the class, take something really complicated, but let people do a little part of it, right? So, for example, we were talking about the drawing team, right? You can actually make like one thing and just say, okay, now we're going to have the simple element and we're going to repeat it 50 times. But it's much better if you have something that is actually inherently complex, and you just say like, well, here's a drawing that's almost complete. We're just going to make like these two little bits of it, but you get the idea that the system itself is capable of producing something complex. And here the question is, for example, if maybe you choose something like refraction gradient, so which is something that maybe high school kids have never seen, maybe you have seen it, maybe not, and look at make a complete list of all the experiments you could potentially support, and use that to derive the functionality for editing.
We really have to move faster.
All right. All right. Thank you so much.